Hi, everyone, and welcome to the Spotlight session on waste, energy, and the ocean. I'm Anna Bossa, and I will be your MC and co-moderator for today's session. I've also been a consultant for the Asian Development Bank's Ocean Health Action Plan since 2019. The ocean is our lifeline. It's a source of various livelihoods from fishing, tourism, and shipping. It's also a source of protein for the world. And it absorbs up to 93% of the world's heat. Without the oceans functioning as the world's largest active carbon sink, climate change impacts would be more intense. The ocean also accounts for about half of the oxygen we breathe, which means that we can thank the seas for every other breath that we take. But we also know that our ocean is in trouble. It has become a dumping ground for wastes, and our fish stocks are declining, and populations of different species are dwindling. But every crisis is an opportunity. In 2019, ADB launched a $5 billion action plan for healthy oceans and sustainable blue economies to boost investment and technical assistance to protect and restore oceans in Asia and the Pacific. And we know that we need to find solutions that are scalable, replicable, and provide wins for both the environment and people. But of course, all solutions come with questions and oppositions, and that's okay. By being open to questions and oppositions, we can find ways forward. This session covers a lot of ground. We look at relationships between and among waste, energy, and the ocean. The ocean has so much potential to provide renewable energy from waves and tidal streams. And these are actually already big topics on their own. And we have an incredible panel joining us today. And it's an international panel coming from Europe, the US, and Asia. We're going to hear from Belinda Bramley, an associate from NLA International, Siete Agama from AWEC, which is a Dutch-based company on waste to energy, Scott Countryman, the founder of Free.ph, working on artificial reefs. And then we'll have a panel discussion after with Dan Milson, who is a consultant on energy for ADB, Francesco Riccardi from ADB, also a safeguard specialist and a marine scientist from ADB, and Amber Sparks from Blue Latitudes, who's working on rigs to reef. So it's an exciting panel discussion we have in store for you, and we'd love to hear from you. You can drop your questions in the chat, and we'll ask the panelists later on. And please identify yourselves, tell us your name and your affiliation and your question. Now, to start things off, because we have a lot of ground to cover, as I said earlier, it is my honor to introduce the Managing Director of ADB for the opening remarks, Mr. Woo Chong. Woo Chong, over to you.
Okay, thank you very much, Anna, for such a wonderful and enthusiastic introduction, and it's a pleasure to be here. Good morning to everybody in Manila and whichever time zone you're all sitting in. I myself is sitting in the United States Eastern time, so exactly the opposite. So in a way, it's actually easy to sort of coordinate timing from where we are sitting. So today's session is about connecting the waste you see every day and everywhere, and how it impacts the ocean and ultimately our lives, which is one of the most important things that we have to achieve in terms of our sustainable future. Indeed, the health of our ocean is major concern for the Asian Development Bank. So as mentioned by Anna just over 2 years ago at the Fiji annual meeting, the ADB made a huge announcement to pledge $5 billion to support the health of our oceans. In this regard, we set up a working group to launch the ADB's action plan for healthy oceans and sustainable blue economies under ADB's Strategy 2030. This spotlight seminar benefits from those involved in the working group and the expertise that are part of the group to provide some insights on where we need to go. Also supported by the Strategy 2030's vision to scale up ADB's collaboration with the other development partners, ADB has recently announced the Clean and Sustainable Oceans Partnership with the European Investment Bank. And of course, we are all familiar with the scourge of marine plastic litter as it is highly visible. But even if we cannot see them with our bare eyes, the microplastics, carbon emissions, and chemical pollutants can also be far more damaging to our environment as well. I hope during this session, the participants can identify areas where we can focus our efforts and funding priorities across the range of challenges which end up affecting our oceans. For instance, funding ocean acidification abatement is difficult to do at scale in a standalone manner. By bundling actions together which have a net regenerative impact on healthy ocean health, we can create the new asset class which sustain and create natural capital. ADB is now focused on emerging fields of natural capital economics, and we have teamed up with the NDRC of the People's Republic of China and Stanford University to co-convene the ADB's Natural Capital Lab. Other activities looking at the inclusion of natural capital assets in accounting standards are also being investigated. When we can value natural capital assets, funding will be much more available for their protection and creation as well. And a recent study in Ireland identified the prospect for the marine or blue economy to double its contribution to GDP by 2030, whilst the Ireland's Marine Resource Plan identified the real map of Ireland was 9/10 of the sea with only 10% of the area being landed. ADB has a number of developing member countries with large marine territories, which can benefit from the development of regenerative industries which provide global common goods. And as mandated in ADB's Strategy 2030, the days of siloed sector thinking are over. If we are to overcome the challenges that we are facing, we need to look for new pathways which focus on creating livable cities and not just building roads, power plants, and power supplies and water supplies facilities. And we must do this for our future generation. And this is the vision of Strategy 2030. I look forward to the outcome of the spotlight session today, and thank you very much for listening, and I hope you can actively participate in this discussion. Thank you.
Thank you, Wu Chong. I know it's hard to speak at 10 p.m., but you did an incredible job. And the commitment of ADB to our oceans will make a huge difference, especially because, as you said, this area, this part of the world is completely covered in our blue planet. And now let's start things off with the presentations. We'll start off with a video, and this video comes from Belinda Bramley, who is an associate from NLA International, and she'll be sharing blue solutions for the blue economy.
Good morning. I'd like to start by thanking Steve Peters for kindly inviting me to speak at today's session on waste, energy and the ocean. I'm Belinda Bramley. I'm a finance professional and independent consultant on the blue economy and nature-based solutions. I'm an associate of NLA International, a blue economy solutions company, supporting governments to implement blue economies that are socially inclusive and ecologically regenerative. I'm also an advisor to Blue Green Future, expert valuers of natural capital, and I coordinate the finance team of Rebalance Earth, a social impact company that seeks to restore keystone species as a nature and climate solution. So as we pass another World Oceans Day, it's a reminder that we live on a blue and interconnected planet. So whether we are talking about waste, energy, or raw materials, we need to think in a circular way. Anyone who has watched the Breaking Boundaries program airing on Netflix at the moment, or has read The Science of Johan Rockstrom on planetary boundaries, will be rightfully concerned that human activities are destabilizing the biosphere, and we are in ever greater danger of reaching irreversible tipping points. Donut economic theory suggests that rather than simply growing economies indefinitely, we should seek to develop economies that thrive within a safe operating space bounded by the planetary boundaries and above a social floor determined by the Sustainable Development Goals. In NLA's white paper for World Oceans Day, The Blue Economy in Practice, we set out a 5-step process for developing blue economies, which raise the quality of human and marine life and of livelihoods through adopting 5 principles. Blue economies should be regenerative of ocean life, adaptive to climate change and new knowledge, inclusive, particularly of those who have the most to lose from declining ocean health. They should be sustainable and they should be evidence-led. Plastic pollution is on the rise, and it's simply one of several pollutants. Thanks to the documentary Seaspiracy, many more of us are also now aware that overfishing is a major problem in the ocean and has led directly to the decline of sharks and rays, a decline of more than 2/3 since just in the last 50 years. On top of that, we have climate change, which leads to sea level rise, a reduced mixing in the ocean and the development of minimum or no oxygen zones, and a decline in the ocean's alkalinity as it absorbs increasing amounts of CO2, and that is termed ocean acidification. And the problem here is that these separate risks all compound to undermine the health and resilience of the ocean. Fortunately, the ocean agenda is also rising. And as I'm recording this here in the UK, the G7 meeting has got underway in Cornwall. The Global Ocean Alliance, convened by the UK, which commits countries to protect 30% of the ocean by 2030, has gained an extra 66 member countries since it was first formed just over a year ago. The High-Level Panel for a Sustainable Ocean Economy is a coalition of 14 world leaders who comprise 20% of the world's fisheries and 30% of the world's exclusive economic zones. And these countries have each committed to fully sustainable management of their exclusive economic zones by 2025. They've also produced a series of blue reports, which provide a wealth of information for governments on how to develop ocean energy and how to confront systemic changes, for example. More countries are starting to value their marine natural wealth. The UK produced its marine natural capital accounts in the last couple of months and valued these at £211 billion. The ecosystem services that delivered the greatest value to that figure were marine tourism and carbon capture. There is a significant gap in funding for biodiversity on the order of $700 billion. The good news again here is that policymakers can deliver much of that much needed finance by simply rediverting existing subsidies, many of which are already harmful in that they contribute to overcapacity, for example, in fishing. I'd like to end my presentation by focusing on 3 types of nature-based solution to the problems of human waste. Seagrass is the most widespread coastal habitat, but much of it has been lost due to pollution and coastal development. It is known for providing important fish nursery habitat and sequestering carbon. But perhaps less well known is that seagrasses can reduce the bacteria load in surrounding seawater and help mitigate the prevalence of disease in adjacent coral reefs. In Australia, seagrass has been shown to sequester metal pollutants in marine sediments, playing a key role in removing metal pollution from the broader environment. And a US study found that seagrass meadows can provide a buffer against ocean acidification for extended periods of time. Regenerative ocean farming is an example of an activity that provides triple wins for people, climate, and the ocean environment. Green Waves model in the US is to produce sustainable seafoods in combination in a low-cost way, whilst addressing nutrient pollution and climate change. A study from the University of California, Santa Barbara, found that growing seaweed in under 4% of federal waters off the coast of California could completely neutralize California's agricultural emissions. The Baltic ecosystem has more or less collapsed due to excess nutrients. Origin by Ocean, a company in Finland, is addressing this problem of excess nutrients through farming and processing of seaweed, which also sequesters carbon in addition to those excess nutrients. And this provides a source material for natural, sustainable ingredients in food, drinks, and pharmaceuticals. Finally, I'd like to end on keystone species, which are those which have a disproportionate effect on their ecosystem. Mangroves, like seagrass, provide multiple benefits. In addition to providing nursery habitat for local fisheries and sequestering carbon more than their terrestrial tree counterparts, they also purify water. They halt saltwater intrusion and protect coastal infrastructure from erosion and storm surges. In this particular example of a wind farm in Pakistan, mangroves were planted around the coastal assets, and the project surmised that the benefits of those mangroves delivered $7 million over a 25-year lifespan in reduced maintenance costs of coastal infrastructure. The whale is a keystone species and an ecosystem engineer that operates on vast scales. Whilst travelling from the poles to tropical latitudes, they transfer nutrients horizontally across the ocean. They also transfer nutrients vertically by diving to the deep ocean floor and back again to the surface. In particular, they deliver iron and phosphorus to phytoplankton, which are limiting factors in phytoplankton production. Phytoplankton is responsible for producing half of our planetary oxygen and probably absorbs a third of the planet's CO2. And as a result of these services of the whale in boosting phytoplankton productivity, in addition to boosting fisheries and delivering whale watching tourism benefits, an economist at the IMF, Ralph Chammy, has valued the services of an individual whale at $2 million. Once you start to put a value on the services of nature, we can create new markets and new products which include the natural world in our blue economy and create regenerative and sustainable value. When thinking about the problems of waste in the ocean, a good place to start, I would suggest, is by looking at natural solutions. I'd like to thank you very much for your time today, and I'll now hand you back to
Thank you so much, Belinda. So as her presentation said, the solutions already exist. And what I loved about her presentation is that she showed top-down and bottom-up approaches so that we know that any way we look at the problem, there are solutions that are already there. So thank you again. And now let's move on to our second presentation, which is from Sietse Agima. He's the Chief Technology Officer of a company called AWEC. I'm not going to attempt to pronounce this. I'll let him do that because it's I can't pronounce it. So Sietse, over to you. Let's talk about waste to energy.
Good morning or good afternoon or good evening. This is Sietse Agema. I'm CTO of AWEC. AWEC is a company who brings high efficiency technology developed in Amsterdam to the rest of the world. And we are passionate about bringing this technology because of the landfill methane production, which is shown here on a landfill in Rawalpindi, Pakistan. We are passionate about it because methane is an 85 times more potent greenhouse gas as CO2 in the first 12 years, and 23 times more calculated over 100 years. And this is actually what we are passionate about, to bring this technology to phase out landfill, especially the uncontrolled landfills, which we find all over the world. This is what we normally see as our consumption cycle, in which we want to bring our technology to phase out landfill and replace it by high efficient, clean waste to energy in order to recover materials which cannot be recycled, but at least we can recover the energy from it and use it as a benefit to the society. And we want to do it in a very, very clean way, because otherwise it doesn't make sense. So these treatments can then eventually evolve into what we call an ecoport, what I will explain better later on. So what we often see is that decentralized waste management often is found in areas, in countries where they cannot afford a decent system, but putting in the right technologies with the right benefits, it should be possible to replace these systems by better waste management systems. Because if we don't do that, then this will be the common practice, that waste is being brought to uncontrolled landfills, often ending up in oceans, the littering of of these processes will end up in oceans, because if it is not controlled and supervised by legislations and enforced policies, people will just get their benefit from what they can take, not caring about what happens with the residuals. We also see that landfills are jeopardizing in several ways the oceans, because first of all, the littering, plastics ending up in rivers and then finally in oceans, but also landfills not properly maintained causes uncontrolled fires, because people need to, the informal sector need time to recover their valuables from these landfills, but often lighting also these landfills, causing uncontrolled fires, and uncontrolled fires causing uncontrolled emissions to the air, and the air is then often rained out into the oceans. So this is what we see here, the effect on the oceans from an uncontrolled waste management system is very clear. I already mentioned the littering from the plastics ending up in the oceans, but also the uncontrolled fires. But also if there is no proper legislation on the emission control of waste management, but industries in general, then we also see that there is a lot of emissions ending up in the air, and these emissions eventually will leach out and rain out into the oceans and rivers. Well, I think the focus of this whole session is that the oceans are jeopardized by all these threats coming from what I call an uncontrolled waste management system and a lack of policies. I think the movie already made clear what the devastating effect is on the oceans. Now in the Netherlands, we have the technologies of controlling these emissions from waste to energy plants. The technologies are already there, and it is possible to have a very low emissions from waste to energy plants. In Amsterdam, our plant is using a dry and a wet system combined in order to reduce the emissions to a very low limit. As you can see on the left side, this is a scheme of our waste of our emission control. On the left side, you can see the high efficiency boiler. There we have the dry system, and there we have the wet system. And as you can see, the emissions levels are way below the European directive demand on emissions. Above here, you can see what we are allowed to emit. And over here, you can see what we are actually emitting. And this is way below the emission levels. And I think it is necessary to aim for that because, like I said, it is possible to control these emissions. So it is not necessary to pollute, especially if you look at the POPs. The POPs are affecting the ocean's life dramatically. And what you can see, we are allowed in the European only 0.1 of these furans and dioxins. And what we are actually emitting is 0.008. So it is possible. The technologies are there. And I think we should also aim for that. Another system which is commonly used now also in Europe is the double dry system, which has the same effect. And actually in these flue gas treatment systems, we are accumulating all the hazardous components which are released in our society. So after we recycled and reused all the products which can be recycled and reused. Still, there is a lot of residual waste which needs to be treated, and we want to avoid that it ends up on landfill. And that's why we treat it in a thermal way in order to recover the energy, but also to make sure that we are accumulating all the hazardous components which are in there and concentrated into the fly ash. The fly ash then needs to be treated in such a way that we make sure that this will not leach out to the environment anymore. So in our process, we make sure that we immobilize this fly ash in a certain component, and we safely store it in a very, very controlled landfill. For the bottom ashes, we make sure that we can clean it in such a way we get out all the metals, all the fractions will be reused, and the minerals will be cleaned in such a way that we also can reuse it again. Well, this was also due to policies which were erected by the Dutch government, because they stated that waste to energy should not have any components left which could be harmful to the environment. So that's why they pushed the industry in order to make it clean and make it reusable again. So now we are in that stage. We developed a technology that we can reuse the bottom ashes in such a way that it is no harmful to the environment anymore. As for the fly ash, I already mentioned, this needs to be treated in such a way that we immobilize it, make sure that all the hazardous components and heavy metals will not leach out to the environment anymore. So I think in Europe, we developed these regulations around emissions. The latest version is what we call the BREF 2019 update of the European Directives 2010. And we pushed these emission limits because we found that emissions, especially dust, but also mercury, and the POPs, the dioxins, are really harmful. To the environment. Dust, as we know, is killing about 8 million people worldwide. It's even worse than smoking at the moment. Like I said, policies and legislation is one of the most important drivers to push the industry to a more cleaner approach of waste management. As we can see in the Netherlands, the first focus was on public health, because we wanted to get the waste out of the cities because of the devastating effect of these of waste causing diseases in these cities. But then by doing that and developing waste to energy, we also created another threat throughout the development of the industry. And that was caused by the emissions of these waste to energy plants. That's why after developing the first and the second generation, this was only meant to treat the waste and get rid of the waste. The third generation was designed to be clean. So in this third generation, we really pushed for the flue gas cleaning, as showed in the picture in the slide before. And this very clean technology made it possible to have these emission levels, as shown also in the slide before, which are very low and very, I think. We could state at first, when we developed this plant, that the air what was coming in was more polluted than the air was coming out. Thank God in Amsterdam that's not the case anymore, but I can imagine that in a lot of countries this is still the case. So then after the solving the issue of clean, we also we now developed the technology where we could have a maximum recovery also from energy, but also from materials. That's what we call the fourth generation. And actually in the port of Amsterdam, we're now developing with what we call the EcoPort. And the EcoPort is more than only waste to energy. It's also about recycling, reuse, but also have an industrial symbiosis with the surrounding industries and sorting and recycling industries. And this all goes together with the development of the policies and the legislation, as we can see throughout the years in Europe. First of all, it was a control and technical fix. Then after that, we started to develop these integrated policies on how to treat and how to recover as much from our waste streams. And the last step is really the step towards the circular economy, in which we want to avoid waste and avoid the use of commodities as much as possible. But we also see that this circular economy really takes a huge effort and also possible a lot of time to really develop towards a completely circular economy. That's why we think also this waste to energy and thermal treatment technologies will be part in a circular economy. EcoPort. So as along with the development of these different generations in waste to energy, also the way of treatment and the way of integrating all these types of sorting and upgrading technologies for waste developed in the same area, and that's what we call a so-called EcoPort. We saw this development in Amsterdam and Rotterdam because we found that we could use the heat and electricity and the energy produced from a waste to energy plant, but we also could benefit from the logistics because all the waste was brought to this same point. So it was easy also to develop these recycling and upgrading technologies at the same area. And in the meantime, we are also thinking further and also in the development of the fifth generation of the waste to energy plant. And in this fifth generation, we think of reusing even more. Also the CO2 capturing of from waste to energy plant is already developing and starting in Europe. Oslo, there is a known plant where they have a huge capturing of CO2, but also in the Netherlands we have now a pilot since 2010 and one demo, a huge demo since 2017. The CO2 is being captured and being primarily used in the greenhouse sector. The greenhouse sector in the Netherlands is huge and is in need of CO2 for growing their crops. So that's a perfect outlet for the CO2 captured at the waste to energy plant. But also in the electrification of the industry, we see that the need for CO2 and hydrogen is necessary. So we see a lot of opportunities for this industry to evolve and develop it. But always from the perspective that it has to be clean, it has to be pure, and it does not, the solution we come up with needs to add to a cleaner society and not pollute it in another way. Yeah, so an improved waste management system really is a real benefit to the society. So that's why we have a big plea for developing ecoports, because if you centralize all the efforts on waste management in sorting, but also treating this waste. You make sure that there will be no leakages to the environment uncontrolled. So you can make sure that everything stays within the area where it is being treated, and it is being treated also in a final way if you use waste to energy. So if you treat it in a final way, you make sure that it is not ending up uncontrolled in the environment anymore, so it cannot enter into the rivers and to the oceans. Besides that, we are concentrating all the hazardous components from this, from our society in the fly ashes, and we will make sure that all the fly ashes will be controlled and immobilized and stored safely for the rest of the life. It also provides proper and decent jobs for the informal sector, because we often find them in devastating circumstances on landfills, and give them a formal status in a decent job. And like I said, if we have a sink solution, as in waste to energy, we will make sure that the environmental impact is limited, because our way of consuming and producing and treating is affecting the environment as we saw it. And in this way, we can make it a decent way of solving these issues and ending the uncontrolled emissions to the environment. And I think incentives from national policies and legislation is really important in order to enforce that. I think also, since we are in the financial institute here at the ADB, it's also the responsibility of these financing institutes to make sure that they will finance only the projects which are really contributing to a clean environment, and not financing industries which are still polluting and making a mess of it. So these were my final remarks. Thank you very much for your attention.
Thank you so much. Thank you for that presentation. We have time for questions. Again, we would like to remind the people watching that you can still send in your questions, drop your questions in the chat. Make sure that you introduce yourself, your name, your affiliation, and send in your question. We want to hear from you, your thoughts, and your questions for the panel discussion and the speakers. So Sietze, I do have a question for you. You cover some of the concerns on waste energy in your presentation, and thermal waste to energy has been criticized as a false solution by civil society organizations. It's not considered wholly renewable, and it takes away, or it can take away, possible investment from other types of renewable energy. And right now, one of the biggest concerns also is that it consumes more electricity than it produces. So I was wondering, how would you convince a government, and let's say the context is Asia, because some of the examples you gave were mostly in Europe. So how would you convince a government in Asia to appropriately size a waste to energy project within an eco-industrial park, as opposed to building just a huge oversized WTE project?
Well, first of all, I want to take away one mistake. Waste to energy is producing energy, so it doesn't cost more energy than it is producing. Especially our technology, which is a high efficiency technology, it produces about 50% more energy than conventional waste energy systems. And therefore, there is a high return on the income from electricity, and therefore you can lower your gate fee. And therefore, it is also possible, especially in development countries, to have this technology in place instead of landfill, because it can compete with the gate fee on landfill. So if there is with the high efficiency, you can make sure that you have a really safe sink for your waste management system instead of landfills. Of course, waste to energy is a solution for our producing and polluting society, which is not really favorable, of course, compared to recycling. But we have to understand and to accept the fact that the way we are producing our goods now, we still end up with more than 50% of waste which cannot be recycled. So in the Netherlands and in Europe, we are almost at a level for municipal solid waste that we can recycle between 50 and 60%. But this goes with what we call the extended producers' responsibility programs, in which the industry invests in this. These facts and these things are not in place in the rest of the world yet. So, and then still, we produce a lot of residual waste which we cannot reuse and recycle. So this needs to be treated. And in my presentation, I also emphasize that in the common practice, if you don't treat it in a final way as in waste to energy, you will find the waste ending up in oceans, in rivers, and in an uncontrolled way into the environment. And this is what we want to avoid. That's why I think waste to energy is a crucial, has a crucial place in the waste management system in order to prevent the environment polluted.
Okay, thanks. That's a good point. I think what I'm taking away from your answer is that not all types of energy are created equal. And we have more time to discuss that at the panel. So thank you for your presentation. I'll see you again in a few minutes. Now we'll move on to the third presentation, where Scott Countryman, who's the founder of Re.ph, will be presenting on artificial reefs. So Scott, over to you.
Hi, Anna. Thank you very much for the great intro. It's been great being part of the MARS project, and I'd like to talk a little bit about our NGO that's been working here in the Philippines for the last 10 years and go through some of the solutions that we've come up with over the last decade to help not only rebuild coral reefs, but work with local communities to involve them in the process. So let's see here. I'm in my presentation right now. So I think there's some pre-operational activities that need to be done, and it really depends on the country that you're operating in. Some are really easy to operate in, other ones are more complicated. And you start out by identifying who the key stakeholders are and having a champion to help support you in the locations where you're going to be doing your coral reef restoration and marine protected area projects. It's also key to understand where your sources of funding are coming from, and that's committed funding, not just soft promises that never materialize. Then conduct your environmental surveys and look for key impacts. Like sometimes we've had to walk away from restoration projects just because of the presence of a large river, for example, that just we're looking like years or decades away from having siltation and plastic from the rivers dealt with. So that wouldn't be a candidate location. And then if having achieved all those other critical checklist items, then mapping the habitat and ranking your reefs by priority. And it's almost like an emergency room triage process where some locations are going to be very difficult to restore, and other areas which have natural resistance would be your target areas to do conservation, and then you identify your locations for restoration. So this process again can take months in places that are very pro conservation activity and restoration activity, and then can take years if ever in other areas. And so our NGO in areas, we did a project that was in a highly populated area. We did another lifeboat project in an area, so sort of suburban population with mid levels of population density. And then we tried another location in a really remote area with very little competition for resources from the local population. So one of the first things to do is to look at preparing your area for stabilization. And here's an example of an area that had been dynamite, had fish bombing activity for decades. And you can see that the branching corals had been leveled into a gigantic rubble field. And it was impossible for the new coral to become reestablished because wave action would roll the rubble around and you would have inability for those new corals to get established. So after laying out a steel mesh and putting a small electric current through it, we used electric mineral accretion to stabilize the rubble field. Within a couple of years, we just let nature do its thing. So this is a very low cost way of doing coral reef restoration. The next phase is coral nurseries and for outcropping back into the reef. And again, this is sort of a thing that goes in parallel. So after you set up your mooring buoys and start your community engagement programs, it takes anywhere from 6 months to 2 years to grow enough coral in your nurseries to start outcropping it back to the wild. So you have to make sure that you have your field operations, your boats and your mooring, and your what do you do during typhoons, and making sure that you're not doing more damage than you are good. In our programs, we try to use only vessels powered by renewable energy using electric propulsion systems and batteries. And I think in the last 10 years, the prices for those systems have come down about 85%. So we think that any coral reef restoration projects that are out there today should be really looking at migrating all their work boats to solar plus batteries. And then you have to make sure that any gains that you've been made are being preserved. So having your a competent enforcement team, whether you're working through the local government, which often there's a lot to be desired with how they're doing enforcement today. So we developed a whole series of off-the-shelf technology tools and sensors to help manage the activity within the marine managed areas. And then using various new technologies like microfragmentation and electric mineral accretion to use a tickle of electricity to rapidly grow branching corals is just sort of accelerates the process. So when you're talking about physical reef restoration, these are areas where we're trying to improve the physical environment where the corals are growing. And so by getting them up off the ground a little bit, it helps to improve the oxygen content of the water, also reduces predators and coral disease. So we found that these 3 different shapes of coral growing structures that are, again, growth is accelerated with this tickle of renewable energy, have been very effective in rapidly growing coral, not only in the nursery environment, but also out in situ. We've also found that after about 9 months of limestone accretion over the top of the metal frames, if the power is turned off, we don't get the benefits to continue to grow coral rapidly, but we do find that the metal frame structures underneath don't rust. So the advantage of that is that natural growth just keeps building on top of the thin layer of limestone that's already accumulated on the structure, and you'll get a natural rate of growth from there. And our goal is to reach this highway parity where municipal governments looked at coral reef restoration the same way they would look at road development, for example, like a kilometer of new paved road in the municipality, and they had a line item budget for that activity. And right now, most municipalities and most governments around the ADB member countries don't look at coral reef restoration as something that needs to be require new investment. They've always sort of taken it for granted that the natural ecosystems provide these services at no cost. The other phase 2 thing is to establish these networks of sensors, and we've developed our own seismic and hydrophone sensors, which not only give us a good idea of overall coral reef health, because we're getting all the background sounds of clicking shrimp and sometimes whales and other things that are in the background. Originally, these were developed for detecting fish bombing activity, and there's some data here that shows that we were able to reduce fish bombing activity from as many as 1,500 plus, or about some days as much as 100 fish bombs per day per sensor within a 24-kilometer radius. And then with community engagement and patrols and awareness programs, we could bring that number down about 90%. And so again, we had a choice of, you spend all your limited budget on planting coral, or do you actually spend that on reducing these hugely destructive fish bombs that, you know, could eliminate a month's worth of restoration work in just seconds with a fish bomb. So again, we shifted our priority to reduce the destructive behavior. Other sensors include the BRUV's cameras, which are automatically recording fish populations. So we can start with a baseline and show the gradual increase in fish biomass and biodiversity in our restoration areas. So there's, you know, time limitations here, but we had some 50 different technologies and programs that we were running across our 3 lifeboat projects. And how do you scale this? I mean, there was a lot of this intellectual property was contained with a very small number of people. So the idea was to document everything and put it in 2 shipping containers that were mounted on trailer chassis. And you could pretty much pack up and ship this entire operation, and not only a command and control center for monitoring illegal fishing, but also a community engagement and educational center, to end water quality managing marine science lab. And you could just pack it up and you put it on a roll-on, roll-off ferry, or if it's in, let's say for Luzon Peninsula, they could just put a semi-rig up to it and tow it to the next location. And within about a month, we could reduce the illegal fishing activity and get all the habitat mapping done. And then it was a law of diminishing returns about keeping those resources all in one place forever. So that we get better usage of our budget by moving the location, the capacity around to get most of the mapping and initial work done in the first month. So moving on to phase 4 is, how do you monetize coral reefs? Because again, that's one of the things. But prior to being a marine conservationist, I was a business entrepreneur. And when you align people's incentives with you know, their own personal monetary gain, then people will support your conservation activity, even if they don't believe in the ethics and the morality of the reasons for doing it. And so one of the things we've identified is actually growing commercial limestone from this electric mineral accretion process. For every 2 tons of limestone we can grow, we sequester about 1 ton of carbon. So our coral growing activity is a carbon sequestering as well. And everything we do, you know, coral reefs are being killed by higher ocean temperatures and ocean acidity. So, you know, if we're emitting greenhouse gases and we're not looking at being negative carbon in everything we do, then again, this is sort of a limited benefits for our regrowing coral reefs. So looking at the $682 billion a year cement industry, there are verticals of everything from paneling, cement panels, concrete, furniture. All of these things could be grown in place, and especially for island nations in the Western Pacific, where they're having to import all their cement and concrete products, they could actually grow substitutes for cement and concrete right in their backyard using renewable energy, and then not only grow living reefs, but also sequester carbon and sell those carbon credits. Another application for this is living breakwaters. So typically, as ocean levels rise, more and more breakwaters are having to be built around the world, and they'll dump tens of thousands of tons of cement and concrete into the water, and that is a net greenhouse gas producer. And you're not creating living reefs. You're basically disrupting the marine environment, and then there's another cost of having to mitigate the damage that's done by building these reefs. So by having ocean renewable energy in place, you can actually grow these reefs every year. So you've got corals that are growing, but then you've got the substrate underneath that's getting stronger and stronger every year to keep up with rising ocean. And there's a sweet spot. There's a little graph here that prepared by Dan Millison, which shows there's a sweet spot in pricing on a per meter basis for growing breakwaters versus the old-fashioned way of just dumping tons of concrete blocks. Another approach that we've been pioneering is the idea of mid-water suspended reefs, where basically you're growing coral reefs in locations where coral couldn't grow before, mainly because of depth. So in this example, we are growing coral in about 120 feet of water, about 40 meters of water. And at that depth, normally not enough light penetrates for the coral to grow really well. But by using this negative buoyancy, or excuse me, positive buoyancy drums to bring these big coral growing trays up near the surface, we can rapidly grow coral and create entire ecosystems in 3 tiers. You have midwater, surface, and benthic environment, which again creates biomass, which is carbon capture as well, in places where there were no coral before. And then to take that one step further, to continue to grow these self-healing ferrocement floating structures, which not only concentrate ocean energy and sequester carbon, but provide tourism activities, dive locations, and even the V shape of this floating island concept would collect currents from ocean plastic from prevailing ocean currents that can be collected in a central collection point. So this is my last slide, which talks a little bit about, we know that, yesterday, I think it was announced that global greenhouse gas emissions exceeded 419 parts per million. And we continue to blow past our targets for greenhouse gas emissions, and it seems to be increasingly likely that the 1.5 degree average temperature increase, we're not going to be able to stay below that. And at that point, even the most conservative scientists, coral reef scientists, are estimating that we are going to be losing as much as 90% of coral reefs on the planet. So what are we doing about it now? Over and over again, in the 10 years that I've been doing this full time, I've heard that it's happening faster than we thought. And they've had to continue to revise forecasts of how quickly we're losing coral reefs, which is, again, 25% of all biodiversity on the planet in our ocean environment. So I believe we need to start looking at like a Norway seed bank-like philosophy of physical coral reef restoration, where we're actually controlling, not in fish tanks and in shipping containers, but actually controlling the water temperature, acidity, and oxygen content of entire lagoons. And there are tens of thousands of lagoons where we could operate these Noah's Ark DNA seed banks for coral reefs while we figure out coral reef sequestering, and we'll have at least that DNA will continue to exist, so we can again hope to repopulate the world someday. Other ideas include the trademark name of Deep 6 carbon, which is a way of capturing carbon at the surface, whether through electric mineral accretion or through growing seaweeds, and then pushing them down into the deep, deep, deep ocean, where that carbon will be captured for 10,000 years plus. And how do we do this at a gigaton scale and contribute to all the efforts around the world that are being done? We did talk about these remote locations that are abundant with ocean energy. How do we monetize that without shipping physical goods across the world? And through digital services like virtual snorkel tours and data centers, we can actually recover and realize that revenue on location, and then use that money for our restoration efforts. And then finally, another idea that Mars is pioneering is this idea of wrecks to reefs or wrecks to coral arcs. And one of the other partners in the Mars program is growing what they call domesticated fish. So instead of capturing the fish from the wild for food and for the aquarium trade, this idea of growing them in tanks, and I know that the one operation in Palau is 90% of their production now is coming from second and third generations. So all of these fish are now reproducing in captivity, and they're adjusted to tank life, and their survival rate is something like 97% versus less than 50% for wild caught fish. And the advantage of this is that it's regenerative. A percentage of all the fish that are grown in the tanks now are being put back on the wild. So there are countless reefs across the Coral Triangle and ADB member countries which have been fished to near zero. And the key cornerstone tropical species, whether they're for food fish or for tourism, these beautiful tropical fish have been now geographically extinct. So this is a solution to use the space boat to help rapidly set up these genesis operations of regrowing fish populations, fish and coral populations, rapidly restocking into the wild. Those are just some big ideas that I think on a global scale, on an ADB scale, on an ocean health scale, would be candidates for this $1 billion in Ocean Health Fund. Thank you.
Thank you so much, Scott. We have a lot, as I said in the beginning, we have a lot of ground to cover, so we'll go straight into the panel. So we'll bring back Sietse and Scott, and we'd also like to welcome Dan Millison, who is a consultant for ADB and an energy specialist, and Amber Sparks, the co-founder and managing partner of Blue Latitudes, an organization working on Rakes to Reef. And co-moderating with me is Francesco Ricciardi, who is a safeguard specialist and a marine scientist from ADB. Fran?
Thank you, Anna, and good morning, everyone. Or good afternoon or good evening. It's pretty early here, so I apologize for my very sleepy face. I would like to start this panel. We have a lot of questions today. I'm afraid we won't be able to answer to all of them, but we will try our best to get as more as we can. So I ask please the panelists to be very short and concise in their answers. So let's start today. I think we can start with Amber, if you are there. So you are promoting this Rakes to Reef approach, which is of course very important in the transition from, let's say, the old time energies to a new method, a new paradigm to use this structure. You have been working a lot in the US. So how do you think is going to be different moving this kind of approach to Asia, where probably you will be dealing with different regulation, different laws, and ecosystems as well? Over to you, Amber.
Absolutely. Thank you for that great question. So this idea, this concept of repurposing offshore oil and gas platforms into artificial reefs, or repurposing any offshore energy infrastructure that benefit the environment, is not a new concept. It's something that has been implemented in the Gulf of Mexico for several decades, and they have many successful reefed platforms, over 500 that have become successful artificial reefs in the Gulf. And we're seeing this program begin to take off in other areas around the world, especially in Asia. Places like Malaysia and Thailand are facing decommissioning of their offshore energy structures and looking for alternatives to complete removal. And reefing those structures is what they're finding is that it's not only a great way to capitalize on the marine life that has developed below the surface, but they're also benefiting other stakeholders, such as the fisheries or local dive people who are interested in going out and utilizing the reef ecosystems that have developed on these structures. So I think there's a lot of potential in Asia. I will also mention that one of the largest contributors to this is going to be the cost savings. In Asia, they've done an estimate of what that cost savings would be. And they estimate that it's about 35 million to decommission in the Asia Pacific region. And that's for your average 6,000 ton platform. But if they were to reef it, it would only be 13 million. So that's a potential cost savings of $22 million. Now, that would be a significant amount of money for both the oil company stakeholders and the state, or however they decide to actually share those costs. In the United States, usually the cost savings is split 50-50 between the oil company stakeholders and the state. Now in Asia, that gets a little bit, sometimes the oil company owners are the state or the nation. And so there can be some issues that need to be worked out there, but that potential cost savings is there. And so it's a great opportunity to capitalize on that.
Thank you, Amber. Yes, I agree. It's a very interesting technology, and really looking forward to see that more developed even in Asia. Anna, do you want to go next?
Sure. There's a question here where The question comes from Sarah Fairhurst. I missed the bit where he talked about generating electricity in the ocean. I love the growing reefs, but how does it link to the generation? Maybe Dan, you can take this question.
Sure. A couple of points. Scott's presentation, I think he skipped over a bit about this process for growing calcium carbonate in seawater using electricity as the input. This process, for lack of a better term, this was discovered in the 1970s in the Gulf of Mexico, where cathodic protection systems used on offshore oil and gas platforms were stimulating the growth of calcium carbonate on the platform legs. And then shellfish were growing on the limestone, and then fish were congregating around the reefs. And Amber's company has done a lot of work on documenting the marine life that grows on offshore oil and gas structures. That's the basis for the Rigs to Reefs program in the United States. Now, the guy who discovered this process, Wolf Hilberts, was very interested in commercializing it to grow sustainable building materials from seawater. He was specifically interested to grow the structures for ocean thermal energy conversion. Okay, well, Dr. Hilberts died in 2007, and most of his ambition died with him. Fortunately, we have people like Scott and Amber around who know something about, the science of all this. Now, what we know from the Rigs to Reef program in the U.S. is that energy infrastructure and other big structures that we put in the ocean attract marine life. Okay, so if we do, we're going to do a wind farm offshore Vietnam. This is going to happen sooner than anybody might imagine, right? We have offshore wind in China already. We're going to have offshore wind in Vietnam next. When you plant those wind farms in the ocean, marine life will be attracted to it. That marine life can be discouraged through the use of persistent organic pollutants like anti-fouling biocides, like tributyl-10, or that marine life can be encouraged. And that's the knowledge base for how to capitalize some of the value of that marine life on those future wind turbines. It will happen. It's not a question of if, it's a question of whether the wind turbine project, the wind farm project, includes provisions to stimulate that marine growth and try to monetize the value of some of that marine growth. That's what ADB's MARAS Technical Assistance Project is all about. Thanks.
Thank you, Dan. So let's stay for a moment in the renewable energy space before maybe moving back to the waste to energy and the waste problem after that. So let's get a very general question. This is about why the renewable energy coming from the oceans is really lagging behind, let's call it terrestrial renewable energy, right? So there is a lot of potential which is still uncapped for the moment. I would like to hear from Dan first a general answer, and then maybe from Amber how she envisioned the use of renewable energies in maybe the Rigs to Reef approach. Over to you, Dan.
Yeah, I think the main reason is that there's a lack of vision on the part of government policy and decision makers about the use of offshore renewable energy. And we're generally we have an offshore wind business that's been that started 30 years ago or so. And just as to use that as a benchmark, in the North Sea in 2015, offtake prices for offshore wind were on the range of $150 to $200 per megawatt hour. And by 2019, offtake prices were down to less than $50 per megawatt hour. That's a dramatic decline in less than 5 years. Why did we get that decline? Because there's a commitment to scale. Wind and solar and other renewable energy, marine renewable energy, are inherently modular and have manufacturing economies of scale. But those manufacturing economies of scale are not realized unless there is a commitment to scale to build more and more renewable energy. The more we build, the cheaper it gets. So today, wind is relatively cheap. It looks really cheap compared to what it was 30 years ago. And today, ocean thermal energy conversion, tidal conversion, and wave energy are where offshore wind was 30 years ago. So if we want to capitalize, if we want to make these marine renewable energy resources and technologies commercially viable, we have to have a commitment to scale. And that doesn't happen by immaculate conception. Governments have to make that commitment. And if they do and create a business opportunity, private sector will fund. There doesn't have to be a huge outlay of public sector funding to get a program like this going. Thanks.
Thank you, Dan. Amber, do you have anything to comment about rig-to-reef and renewable energy, maybe?
Absolutely, yes. I second what Dan has said. I believe that there's incredible opportunity for it, and in many ways it's already underway. It's just a matter of continuing to prioritize it from both a governmental and an industry perspective. Right now, we are looking at decommissioning these offshore platforms. And in many cases, traditionally, that just means completely removing the structure from the seafloor. The concept of rigs to reef would be to leave a portion of the structure in place so that it could function as a marine habitat. But what if you left the upper portion of that structure in place as well, the top side, what you would see from your beach chair, and you repurposed it for wind energy, or you stored wave energy batteries there, or gave it a second life in terms of being capable of producing alternative energy. The great thing about these structures is that they already have the cabling from onshore facilities. The infrastructure is already there to house another type of energy. It's all about collaborating between the industries and becoming aware of the opportunity and then taking advantage of it. And I know that those conversations are already underway.
Thank you, Amber. So since I think Anna is not on the screen, I can maybe give a couple of more questions. So let's move back a bit on the waste to energy and the waste problem in general terms. So maybe Sietze, I think you are there. So there is a question about the total cost per metric ton of waste incinerated. If you can give us some, let's say, some indication about it. And also, of course, waste is important to. The first thing we should try to do is avoid that the waste get into the ocean. So, are you aware that there are clients for this kind of technology to avoid plastic waste going to the ocean directly? So, is there a measurable percentage that can be used for it?
Yes, thank you very much. About our clients, is mostly governments. So if the awareness starts at governments that they should do something about their waste problem, then they often reach out to suppliers of waste to energy. Often it starts when landfills are full and they have to start to build new landfills. They think of, hey, maybe there's a better way to treat this waste, and then often we come in. landfills in the western part of Europe is not existing anymore. So the northwestern countries like the Netherlands, Germany, Finland, the Scandinavian, they don't have any landfills anymore. They have their final treatment in waste to energy. So that's completely phased out, and we see now also, luckily, other countries are moving that way, because as I showed in my presentations, I think the recycling efforts and landfill is of the recycling efforts. It's not sufficient to treat all the waste. There is still a lot of waste which cannot be recycled and needs to be treated finally in technologies like this. Hopefully we can phase it out, but it will take decades most likely. Now about the cost, it really depends, especially if we look at our technology. That's why we increase the net efficiency of the waste to energy in order to gain as much income from the electricity, and therefore we can bring down the gate fee. So in some countries we can the electricity price is so high that we can do it without the gate fee. So then it's actually a total benefit from the production of energy. Other countries we use a little gate fee, and like I said, it's competitive with landfill at the moment. You have to think about this cost. So waste management in general, you have to always to envision that it is trying to treat waste at the lowest cost for society, because eventually we are producing waste, and this waste needs to be treated, and we would like to bring down the cost for society as much as possible.
Thank you, Zetse. So there are a lot of questions. I'm struggling to follow all of them. I would like to go back to probably the first question we got. It's very important, I think, in this space to be aware that the problem can be approached only by a multidisciplinary strategy, which involves not only energy, but involves environment specialists, also the transport sector. And we have a question at the very beginning, which is related to the use of cleaner vessels. So I guess we're focused until now, for example, on large ocean-going vessels that can be powered by renewable energy. But what about small vessels? So there is a huge fleet of people, fishermen, that use small vessels for their livelihood and for coastal economies. How can we help these people to get out of the use of fossil fuels and go into the renewable energy space? Maybe Ben, you wanna comment on this?
Sure. The 3 points. First, the economic case for vessel conversion, retrofit, or replacement is that the operating expense savings will pay for the capital expense, the additional capital expense of the retrofit or the new vessel. The business model is critical because we need to be able to service a very large number of very small investments. So for Asian Development Bank, this can be done through a financial intermediation loan. Now, the business model, we need something like a cash for clunkers program where, say, we have a service company that's being funded with ADB financial assistance. The service company can buy the boats from poor people, which puts money in their pocket immediately, and then we sell them on a pay-as-you-go basis a newer, cleaner vessel. For retrofits, now, I mean, Scott knows how to build solar-powered boats. He's done a few. I've been on his boat down there at the Sigbu. there isn't any lack of technology. The financial and economic case can be pretty compelling. For ADB to provide this kind of a program, a government has to request it, or a non-sovereign client has to come forward and request it, and that hasn't happened yet. When that happens, ADB should be all over it like a cheap suit.
I don't know if it's me. Then you're still there?
Yeah, that's it. Thanks.
Okay, thank you. Thank you then. Yeah, this was a very interesting question, I think, because we need to start thinking about moving out from fossil fuels, even in the end users, right? And another thing we can think about, for example, is the large subsidies that governments are giving to large fleet, for example. Okay, so we still have a few minutes. I have a lot of questions again to on my list. Probably we can go to Scott very quickly. We have very few minutes. So one question is about the space of the integration of different activity in the ocean. So which policies and regulatory mechanism, and how do you balance the various usages of ocean? It can be fisheries or reef restoration, and together with the livelihood and community users.
Okay, yeah, I saw that question. I think that the sort of misconception is that these restoration programs somehow hurt people who are subsistence fishermen, and where it's just the opposite. Right now, with very little management of the resources, at least in the Philippines, they're fishing to zero. So coral reef fish populations in most of the areas that we work in are down 90–95%. And so by setting up coral and fish nurseries in this 30% by 2030 policy, we're actually helping the people who are subsistence fishermen, who are basically relying on the ocean for their animal protein. And so there is this gap, maybe 3 to 5 years before you see your restoration efforts translate into increased fish catches. But from our experience, the local people want the jobs, and they want this bridge to get them through a trajectory right now, which is to fishing to zero, to a future of abundance. And so if you can give them jobs, you can give them community-based programs, they enthusiastically get involved. You put, uniforms and small fiestas and celebrations of achievements, educational programs where the kids can not only improve their swimming skills, but also learn that coral reefs are alive and essential to their maintaining their fisheries and their future. It's education, it's awareness, and it's participatory regeneration. So yeah, they're part of the solution.
Thank you very much, Scott. Okay, let's finish with a vision that we have. Is a very interesting vision that we have on our chat box. Is a vision of areas offshore where there are floating wind turbines, floating sonar, and other ocean regeneration. This energy is used to produce hydrogen that can be shipped everywhere to shore and to allow this transition from fossil fuels. Can I ask Dan and Amber to give us a very quick thought about this before passing over to Steve for the final remarks?
I'll take it and let Amber have the last word. That's a great question. If we're again, the usage case is very important. If we're just trying to sell electricity from floating or offshore renewable energy back on shore, today we've got offshore wind and we've got marine floating solar that's competitive against diesel generation. And we've seen commercial deployments of marine solar in Norway and the Maldives. There's a new project going on in the Seychelles, and some under development in other countries. If we forget about the power purchase agreement electricity sales model and think of captive generation, power to X, what is the productive end use of the energy and what is the value of that project, of that product? For example, if we grow limestone building materials, if we're trying to grow just limestone blocks, we're selling against quarried limestone, the market price doesn't look very good. If we go to non-structural limestone tiles, those retail for more than $3,000 per ton of limestone. The implied value of the electricity generated from offshore renewable energy to grow that limestone is on the order of as high as 60 or 70 cents per kilowatt hour. So we have to get outside of the electricity power purchase agreement box to get to the monetization of that offshore renewable energy. Thanks.
Thanks, Dan. Amber, 30 seconds for the last thought.
Wonderful. Yes. Well, I can definitely close us out by reminding us all that our oceans are resilient and they have rebounded in ways that we did not expect. Great example could be on the underbelly of a offshore oil and gas platform. And through this, we've found opportunities for industrial growth, new ways to think about offshore energy and offshore industry, and ways to upcycle existing materials, all really positive and exciting things on the horizon that we just need to go out and really take advantage of. So excited to share that with everyone here today. Thank you.
Thank you, Amber. Thank you, all the panelists. And thank you, of course, Anna, to moderating the session at the beginning. Over to you, Steve, for the final remarks.
Thanks.
Thank you very much, Francesco. Thank you to everybody who took part today. I appreciate people who are in different parts of the world, and I also appreciate the support of the Managing Director General of ADB. Him coming to present, to do the opening remarks shows how seriously we take it. I would like to first recognise that we didn't give Amber enough airtime today. Amber's got a fantastic business which she operates with her partners called Blue Latitudes, which does some exceptional work, and they are a commercial operation at the moment. Dan and some of the other folks talked about that the solutions are already here. There are solutions happening in this space, but we tend to see the ocean as something that is far away or something that is not touchable or something that is not investable. Well, that's just simply wrong. What we're seeing at the moment is the beginning of a huge change in seeing the ocean as something that we need to cherish, but also that we need to develop in a way that we make it regenerative. Amber talked about the resilience of the oceans, and that resilience is something that we can't take for granted. We have to build processes that are regenerative. I'll give you a great example, doing offshore wind to make hydrogen, but co-locating activities like marine aquaculture, doing the cultivated reefs, doing the regenerative aquaculture where you put fish back and you put marine creatures back into the environment, but use that mechanism to protect the assets that are generating electricity and helping us further industrial growth. Now, to do that, we also need to protect ourselves against pollutants. And when we talk about pollutants, I don't just mean nutrients in water or even the most dreadful of them, which are persistent organic pollutants, which we find from industrial processes, including waste to energy plants. So Sietz's point about locking up pollutants and POPs from fly ash is tremendously important, and that's something that we will take as a major priority going forward at ADB. But also we need to look at carbon as a pollutant. Carbon's making our oceans more acidic, and it's having an impact on marine creatures. The exact amount of that impact and how devastating that'll be, we don't really know yet. Reports were recently released about impacts from climate change, and what was glaringly obvious was that there was very little quantification of the impact of acidification. So carbon's a pollutant in the ocean. Not only is it causing global warming, but it's also causing acidification, which stops those marine creatures, which Anna talked about, which produce half of our oxygen and sequester a third of our carbon. So looking at some of these opportunities where we can say we can sequester carbon by growing reefs or other activities, supporting the growth of marine life, and also reinforcing natural carbon capture and storage, and doing it perhaps with man-made carbon capture and storage, but the market will determine what the rate is. If industrial carbon capture and storage is $100 a tonne, but it can be done at $5 a tonne by growing marine reefs, I wonder which one people are going to pay for. And the obvious example is the cheapest one. We have 1 trillion tonnes of excess carbon in our environment. That's an enormous number. Scott talked about a gigaton solution. So that's 1/1000th of the problem. But we need to look for these solutions because we need to respond to this problem. And I think looking at oceans, not purely and simply as a place where we strip mine minerals and fish resources and we use it for transport, we need to look at it a little bit more holistically. And the takeaway point, and I'm going to reinforce Amber's point, is that it is available to develop the ocean's resources and use them for our benefit in a way that responds to the challenges of climate change. So I think the takeaway from this, this panel is really going to be that whilst it is a complex place, there is a lot of things going on, there are a lot of threads. If we push forward with an agenda to provide regenerative systems to maintain that resilience in the ocean, we can look at doing all sorts of activities. We can look at doing monitoring in the sea. We also can look at doing supporting activities like the protection of large marine mammals, which Belinda talked about. Their impact on the ocean, we don't know exactly the details of how much these impacts are, but we need to do more research and we need to put more money into this space. I spoke to someone recently that said with $378 trillion in debt internationally at the moment, how do we create the industries to create the growth to start paying that back? The answer is very simple. We need to avoid having sea blindness and we need to focus on where the opportunities are in the ocean. Today's just a bite in what we're doing. We are undertaking a TA at the ADB called the MARES TA. It's a very long name, but I encourage you to do a Google search, which is ADB Marine Data Room. And on that, you will see a data room on Development Asia. I won't give you the link because it's just too long. And you can look at what we're doing. And we will be providing webinars and more detailed information from the participants today. And this talk will be loaded up. So on that note, I'd like to close and thank everybody for their efforts. The show doesn't stop here. We've got a lot more work to do and we invite you to take part. Thank you very much.
Thanks, Steve.